Welcome to this video about devon4j Kafka. In this video, I'll be giving an introduction and also a demo how to integrate devon4j Kafka into a Spring Boot application. Now, let us see why we need devon4j Kafka. First of all, we use Spring Kafka. Yes, devon4j Kafka is built on top of Spring Kafka. So, you get all the features of Spring Kafka and also from us. We provide many support classes for configuration and error handling, which reduces your work effort by 60%. As I said before, we provide many configuration classes for producer, consumer, Brave Tracer, and message retry processing from devon4j Kafka. In this video, I'll explain one by one. One of the important feature we provide with this devon4j Kafka is custom message retry pattern. You can use this while processing the consumed message. So the first step would be you have to provide exception name for which exception the retry has to be performed and the retry count for how many counts the retry has to be performed in the application.properties file. So when a particular exception is thrown, the retry will perform again and again for how many retry counts you have provided. Another support we provide is monitoring support. This is done using Spring Accutator. We check for the topic only when the leader is available. If not, broker connection alone is checked. And the next thing is tracing support. This is done using Spring Cloud Sleuth. We inject B3 headers from Brave Tracer, which is trace ID and span ID, into the producer record headers. So when you consume message for the topic given, along with the other headers, you will receive these two headers also from the consumed message record headers, so that you can track the asynchronous process of producer and the consumer. The next thing is logging support. We have some aspect classes which listens for the producer and the consumer, and it logs immediately once the message has been sent and consumed. And also we have some other logger support classes which logs the different level of retry pattern and also some other error handling failures. Now let us focus on the code, and I will show a demo to integrate this devon4j Kafka into a Spring Boot application, and also I will write an integration test to see how this devon4j Kafka works. To know more about this devon4j Kafka, go to our website, which is www.devonframework.com, and click on Get Started, and you can find the devon4j, which is a Devon framework for Java. Click on that, and you can see Guides section. Click on that. If you scroll down more, you can see a lot of guides with various versions available on devon4j, and you can see the messaging services. Click on that, and yes, you can find a lot of description available for this devon4j Kafka. I have given a deep description how to use and what are the parameters you need to pass, and with along with some more examples. And you can find the naming convention for the topics which you need to maintain, and how to send messages and how to receive messages, and you can find diagrams for those things, and architect, and also you can find an architectural diagram for retry pattern where you can understand more clearer how this retry works. Now let us see how to create a simple Spring Boot application using Devon framework. For this, a Devon IDE is need to be installed on your working machine. As I said before, if you do not have Devon IDE, check out our YouTube channel. A video is already available explaining how to install Devon IDE. After installing Devon IDE, please go to this same page devonframework.com and click Get Started. And after that, click on Devon Framework for Java and scroll down and click on Tutorials. You can see here there are some description available how to create a new application using Devon Framework. There are two ways to create this application. either by using devon command or by using a maven command for a low level creation. Since our application is just a sample demo app, I'll just go with this maven command. You can follow any of this step to create your own application, and also you can create your application through Eclipse by following these simple steps. After installing Devon IDE, please go to this work. So this is where I installed latest Devon IDE on my machine. You can check the version name in the folder name itself. You can see here 2020.04.001, which represents April of this month. This is the latest version happened here. So once you came here, do a right click and open Devon framework command shell here. Expand it and paste your maven command which I used to create the application. So you can see here the DR type, the devon4j version will be the latest version, and group ID is the devon framework templates, and arc ID is same devon4j template. And you don't need to worry about giving all these details. If you use the first command which we saw in the devon framework, it will create automatically. So here comes our application -d group ID which I set here, and the artifact ID which is a Kafka demo, and our application version, and our application package structure which should be a source package, and the DB I want to use is h2, and dbatch is about the spring batch. For this demo I don't need a spring batch, so I'll just erase it. If you don't want to use batch, you can just leave it this command empty. So after doing all, just click and enter. Let the command create the application, and you can see here our application got created with the parameters we have given, and also with the required Devon dependencies. Now you can see the created application in the same location of Devon IDE got installed. You can see this Kafka demo folder. This is what the application we want to create. If you open this, you can see the API, core, server, and the pom.xml file, which is of type of Devon framework structure. Let us import this project in our Devon IDE Eclipse. To open the Eclipse installed with the Devon IDE, click on this eclipse main.bat. So the bat file will load the appropriate commands and will initiate the Eclipse IDE. Now the Eclipse has been opened. Now let us import the application which got created. Click on import projects, click on Maven, and click on existing Maven projects. Next, and click on browse and choose the location where it got installed. So I kept in C projects, Devon ID latest version, and the Kafka demo, and select this folder. So it will select all the pom.xml files of each and click on finish. So Eclipse will be importing this project, and we'll do a workspace build. So once the project is imported, it will look like this. If you find any compilation error after importing the projects, I suggest you to update the Maven project and also do mvn clean install on each module's pom file. Now let us take a look on the imported application. Kafka Demo API is the place where all the REST templates and REST layers will occur, and Kafka Demo Core is the place where the business logic codes will happen. Now let us go and add the necessary dependencies which we require for our sample application. So on the POM file of core, let me open this, and at the last I'll just add the dependencies which we require to run this Kafka, devon4j Kafka. Yep, I hope this place will be fine. Yes. So first, there are two starters which needs to be imported to run this devon4j Kafka. One is devon4j starter receiver and devon4j starter sender. If you want to use only the producer classes and tracer from the devon4j Kafka, you need to import only the sender starter. And if you want to use receiver configuration like listener container factory and retry operation along with producer, then you need to import receiver starter. Since I need to use both producer and receiver in this sample application, I will import receiver starter. So let me add the receiver starter. So inside the dependency tag in the group id com dot devon framework dot java dot status. In the artifact id devon4j hyphen starter hyphen kafka hyphen receiver. So this is the dependency starter for the devon4j starter receiver. Now the Eclipse is downloading the source for the added dependency. Before adding the next dependency, let me explain what I'm going to do in this sample of Kafka application. I'm going to write the integration test where we will be sending an information of an employee through to the Kafka broker using devon4j Kafka sender, and the listener class will consume the employee information from the Kafka broker and it will save it into the DB. This is what we are going to do in this application, and it is a complete integration test. So you need to download the Kafka and run it in the background before running the test. Now I have added the second dependency which is required to test the asynchronous process. Awaitility is a dependency which is used to test the asynchronous process. The assert statements will be like it waits for a particular amount of time until the condition becomes true. Let us see more about this while writing test case. So now the next thing is to add the property fields to the configuration of devon4j Kafka. Let me add it. So in the src main resources of core module, open this and open this application.properties, and at last I am pasting the properties which required for devon4j Kafka. All these properties you can find in the sample Kafka application. The link for the sample application is given in the documentation. You can find it in our Devon framework page where I navigated you before. Now let us see what these properties are having. So it has some common properties which is common for producer and the consumer. This is the main property which is need to be mandatorily set by you. So bootstrap servers, this is where the producer and the consumer will contact and exchange the message. This localhost 9092 represents where the Kafka broker runs in my local machine. If you use Docker instead of Kafka directly, you have to provide your appropriate broker server ID over here. So moving on to the next, here we comes for the Kafka health indicator properties for the monitor support. This property tells whether we need to perform the monitor support or not, and this is the topic which we are going to send the message and the topic to check, and this topic followed the naming convention which is specified in the documentation. You can have a look at the documentation and check the naming convention for the topic. And the next is Kafka producer properties. In this, the main mandatory properties is the serializer, the how to serialize the message present in the producer record. Here I am using the string serializer from Apache Kafka. and if you want, you can provide the other serializers like JSON serializer. And next is Kafka message sender properties is used for one of the method is in the message sender of devon4j Kafka. I'll explain about this while we are coding the test class. And moving on, it's a Kafka consumer properties. Here the major important properties which is need to be set by you is a group ID and the deserializer. Here once again I'm using the string deserializer, and if you want you can provide your own deserializers or other deserializers present in the Apache Kafka. The next property is the Kafka listener container properties. Here I have set the concurrency for the listener container is 1. You can set the other numbers you want. Moving on to the retry policy. This is where the properties which all is required for the to perform the retry pattern. Here all these values have been provided with the default except the retry count. Retry count is the where I initially said how many times the retry has to be performed, and the retry period is also provided with default values. Here this 1800 represent the seconds. If you want to override, you can provide your own value over here. So in this example, since I'm going to save the consumed message into the DB, I'm keeping the runtime exception, which is SQL exception. So whenever some SQL exception happens in between, I want it to be retry. And the next one is retry exception traverse causes. I specify true to traverse this SQL exception. We use Spring configuration to map these properties to the fields of configuration. The prefix mentioned in each configuration classes is same as mentioned over here. So we recommend to keep the same order and not to change anything, just to provide the values, to override the configuration values which is provided by default values. You may wonder why some of these properties are commented and others are not. The uncommented properties are mandatory properties which is expected from the user. The commented properties are already given by the default values provided in the configuration. However, you can override it by providing your own value specifying in this properties files. Now, the next step is to create a entity class. So inside the core, open the source main.java and the kafka.demo. Like general, we need to create another package which is of type which is more relevant. As we are dealing about the employee, let us make it as employee. So demo.employee, and inside this we will create one more package which is dot data access, and inside that I need API. So inside this API I'm going to create my entity class which is employee entity. I don't need the author tag. So inside this what we need to do is just create the string variables which we require. The first one will be the name of the employee, private string name. The next one will be the age, private integer, age, and the next one will be private string location. Now what I'm going to do is I'm going to use one of the feature of Devon framework, that is a CopyGen. It is a code generation tool. It will generate code from the entity class you created. It creates a REST layer, repository layer, CTOs, ETOs and extra. You can use your own template or choose the one which is already available. If you want to know more about CopyGen, check out our YouTube channel. A video is already available explaining what is CopyGen and how to use CopyGen. So once you're done with the employee entity, right click on that employee entity and click on CopyGen and click on generate. This will take some time to choose the appropriate template for this employee entity, and it's loading. And to know how to install this CopyGen template in your working IDE, you just have to watch the video which is already available on our YouTube channel, which describes how to install and how to use. So it got finally loaded. Let us choose the needed generated codes. I need the REST layer and I need the repository layer. You can see the classes which will get generated. It is already showing here. This is kind of preview. And I need the UC logic, which will have the generated code which interacts with DB. And I need an entity infrastructure for the entity class we created, and the TOs, which will have the search criteria to the DBs. So if we click next, and this confirms for the fields which we created in the employee entity, and click on finish, and this is generating the files now. Let us have a look once it got generated. So now let us open the API part first. If you see, open sassy main.java and open the package Kafka demo, and you can see a package employee is got generated automatically because we created the employee entity in the package employee. So if you open this, you can see the common API employee.java. It creates an interface which extends application entity from the devon4j. So let us have a look at the other classes, the logic API, the TOs which we got selected, and the employee search criteria, which will be very useful to search the employee using passing these values. It will match with the same values provided in these fields and will fetch the result from the DB. And the use cases, these are the interfaces. As you can see, we didn't write all this code, it got generated automatically. We chose Spring Data layer, so all these classes and methods which will interact with the DB is got generated automatically. And this is to find the employee, and this is to manage the employee, which is like saving and delete. And here comes the main thing, service slash API slash REST. So it created a REST layer for us automatically. It has some few methods, and we can add our own methods over here. Now let us close this and let's move on to the core part. Here only we will write the business logic layers. So if I open the main Kafka demo and employee, if you remember, we created this package data access.api. Inside this, a repo package is created, and the employee repository has been created automatically by CopyGen. So this interacts with the DB and gives us the result. So after this, here comes the employee entity. If you remember, we just created a class and these three fields, and the CopyGen has taken care of all the rest of the actions. And these two are from the employee API classes. Now let's move on to the logic package. In the Impl, you can see the use cases for the implementation for the interfaces we saw in the API, and the employee IMP in the REST layer, and it's an implementation for the REST layer. Before moving on to the coding part, we need to create a DB schema file for the entity we have created. The entity we have created is placed in the core module, main, Kafka demo, employee, data access API, and this is the employee entity. And if you can see, the employee entity extends the application persistence entity by the CopyGen code generated. If you open the application persistent entity, it will have some two important fields, id and modification counter, which will be automatically mapped to the whatever the entity we create. So this modification counter will be automatically incremented whenever you modify the employee entity table. So let us have a look at the db schema file I have created. If you can see, this ID and modification counter is part of application persistent entity. It is important to include this also in the db schema file as we are using Spring Flyway database. So as we are using H2 database, we need to use the H2 syntax to create the db schema file. So since it is ID is of type long, we are using big int, and modification counter is a type of integer, so we are using int. If you compare this with Oracle DB query, you will be using in number here instead of big int and integer. So as we are using H2, we need to go with this. So name is a string. I'm using varchar, and age is a integer, and location is a varchar, and I'm using primary key for this ID. So and I have created this file in the same core module in the main resources db migration 1.0, and this is the file which we have created. This file create sequence.sql will be automatically created when you create this Spring Boot application using devon command, and all these folder structures are all part of the command which you when you create a devon4j application. Now let us run the Spring Boot and check whether all are fine or not till now. So this is the Spring Boot class which we need to run present in the core module. Right click, or else you can use the shortcut also, run as Java application. So let us have a look whether everything is fine or not by running the Spring Boot server. There is an error when we start the Spring Boot application server. This is because the diagnostic context packet. This is a class where we use to create a UUID which will be passed in the HTTP address of each web request. So this is happening because it is the same bean class has been used in the devon4j Kafka also, where we used to create the UUID and pass it in the Kafka headers. So by default, the devon4j Spring Boot application also uses devon diagnostic context packet. So here we have an action to solve this error. Consider making one of the beans as primary, updating the consumer to accept multiple beans, or using qualifier. I suggest to go with @primary because in devon4j Kafka, we check whether the UUID is already present in the diagnostic context packet. If it is not there, then only we are creating a UUID. As the devon4j Kafka application is automatically creating a bean for the UUID, I suggest to go with @primary. So now let us have a look where to place this annotation. So this is the class path for the devon4j Kafka. I don't want to add it over here. I want to add it in the devon4j Spring Boot application. It is in the demo general service impl config. Now let us go and add the annotation over there in the same core part service. We need to go inside the general service impl config, and here it is. Open the web config, and we have to check for the bean of, yeah, here it is, diagnostic contact packet, and it's a bean. You can add the @primary annotation over here, which is from Spring Framework context annotation. So this makes this bean as the priority one from the one which is used in the devon4j Kafka. Now let us again rerun the Spring Boot server and make sure everything works fine. So the server is launching now. We will have a look once it is run successfully. Whoa, whoa, whoa. There is a multiple errors have been thrown, multiple exceptions. What are all these unsatisfied dependency injection? Usually devon4j Kafka application should be able to handle the dependency injection for the classes they create. Let us have a look at the root cause. Error creating bean with the name employee Impl, which is used in the UC layer. Okay, and for this the reason is the error creating bean with the UC employee Impl. For this again the root cause is error creating bean with the employee repository. It goes layer by layer, so something wrong with the things which we did. Here comes the root cause. Illegal argument exception, not a managed type. Employee entity. It's exception thrown from Hibernate. I think we missed to add some annotations in the entity class. Where is our entity class? Here. Thank God I already opened it. Yeah. If you notice the entity class, we forgot to add that this class is an entity. We need to add the entity annotation, and also it's better to name the table instead of having the table name as employee entity. So at the rate table, and the attribute will be name equal to, let it be employee. Okay, now close all these failed logs. I don't want to see it. Now rerun the Spring Boot and check. I hope everything works fine now. Let us have a look once it is finished and it's launching. Yeah, okay, now the Spring Boot application has been started. Now let us dive into the coding part. Okay, now it's time for coding. As I said before, I'm going to write an integration test where I'm going to send a message to the Kafka broker using devon4j Kafka message sender, and I'm going to consume it using the Kafka listener from Spring Kafka and going to save it in the DB as an action of consumed message using message retry pattern from the devon4j Kafka. Let's dive into the code. So, in the core module, I have opened the src test/java's source folder, and there will be a folder already with com.kafka demo. Under that, I created a package called employee. Now, under employee, let me create a package. So, it will be service test, service, impl, and it is a rest, of course. So, I've created it. Now, under this package, let me create a test class. Uh, what can I name it? Kafka demo service test. Maybe. Okay. Now this has been created. Now this should extend the code from the devon4j Kafka application, which is REST service test. So if you see, when you create a devon4j Spring Boot application, all these classes will come with you. It's automatically generated one. If you open this, this will extend to the subsystem DB test, and it's a Spring Boot application test, which will use for the integration test. So now let's close this, and yeah, let's reopen it. I need to inject a field, the message sender from devon4j Kafka, private message sender. If you can see, it is an interface from Devon framework module Kafka messaging API client. Double click on it, and you need to specify the type. So now I'm going to keep it as string, comma string, and message sender color, and inject it. Inject is from Java X inject. That's all. Now let us create a getters for that. Right click, source, generate getters and setters. Just select the message sender alone and generate. Oops, I think it created the set method also. I don't need it actually. just erase it. Let's keep things simple with just get method. Okay, now let us go on to the part. Now I need to write a method public void should send message and save it in db when producer record is given. I love long names, it explains more clearly than Java docs. Okay, so now using the message sender, the one which we used before, get message sender dot these three methods are the available one which we have written over there. Let's choose one, the send message, and it expects a producer record. Now let us create the producer record. This part will be act. Now let us do the arranging the things for the act. So it requires a producer record. Let us create a local variable equals new producer record, which will have the topic and the value will be the employee object. Alright, so I need to create employee, and the topic will be the one which we passed in the properties of health check. Let us go to that. Source main resources config. Oops, not this one. The main application.properties file. Go over there and Kafka health check. Yeah, this is the one. We have followed the naming conventions for the topic. We suggest you also to do the same. So this will be the topic, and now we need to create a employee object. Oops, it should be under arrange. So how it will be employee ETO. I don't want to use the entity class because it reveals the ID of the user. So I want to use the ETO which we created using Cobigen. So this will be employee object equal to new equals employee ETO. Now we will set employee dot set age. Age is of type integer. Let me add some age randomly, a youngster, 24 maybe. Employee dot set location India. Employee dot set name random name Ashwin. So if you see here, we have chosen string comma string, which is of key and value type. Here the key should be string and the value should be string. So let us convert this employee into a string using object mapper. So let us do new object mapper dot write value as string method will be there. Yeah, here it is, and just pass the employee object. Now store it in a variable of type message, and it will be string. Now pass this string as the message to the producer record. There is a compilation error at the object mapper that is of type because this method write value as string throws JSON processing exception. Let's surround it with try catch. Yeah, that looks good now. So instead of this, let us add the loggers. Okay, fine. Here private static final logger interface from devon4j log equal to logger factory, same from devon4j dot get logger of this Kafka demo service test dot class. Now log it with a meaningful message. Log dot error while processing object to string. Maybe we can change this to into a more meaningful way. Error while converting, instead of object, let us pass the employee to string, and let me pass the employee object. Okay. Now there is one more compilation error on the producer record, which says the local variable message may not have been initialized. Okay, let us initialize this equal to null. That's it. So now we are finished with the arrange and also the act. Now we need to assert it. Before moving on to the assert part, there is still something pending on the arrange part, which is providing access to the employee REST service, which we are going to use it for the assertion. The devon4j Spring Boot application by default provides some Spring security implementations like form login. So it is required to give access for the REST service which you are going to use to assert the values whether it got saved in DB or not. If you open the API module under the employee package in the service API REST, this is the REST service which got generated through Compilation, and it has multiple methods which was automatically generated and also interacts with DB. In these methods, we are going to use find employees in the assert method to check whether the employee object which we passed in the producer record got saved in the DB successfully or not. So we are going to hit this API. So in order to hit this API, we need to give access to it. Let us see how to do it. So let us create it. Employee REST service, the REST layer, and the object name will be the same, equal to get service client factory, which is from the interface, sorry, the class, the REST service test. The method will be available already. Dot create the employee REST service dot class, comma, new service client config builder dot host is the local host which we are going to test on. Localhost dot, we provide basic auth with the user login is admin. I'll say why I'm passing admin over here, and user password is admin. Dot build map of, and give the semicolon. So here we have created the service client factory for the REST layer which we have created using Compilation, and the username is admin and the user password is admin. I'll say now why we have given admin and admin over here. In the core module, under the general package, inside the service.impl, inside the config folder, there is a base web security config which will configure the Spring security. Open that, and if you scroll last, there is a method called configure global, and only one user is in-memory authentication. It uses in-memory users, which is of type with the user admin, and the password is admin, and the role is admin. This is why I've passed admin and admin over there. So we have finished with creating the service client factory for the REST layer. Now let's move on to the assert. As I said before, I'm going to use awaitility dependency class. So let me use it. Awaitility dot await dot until my condition becomes true. What is the condition? Use the lambda expression over here. The condition is employee REST service, not this, employee REST service dot find employees. We need to pass the such criteria here dot. Okay, first we'll fix the compilation error. So create a local variable for this, employee search criteria equals new employee search criteria to. So I created object. Now let us set the search criteria. Search criteria to dot set age, the one which we passed in the employee dot get age dot set name as employee dot get name, and at last with the location. Search criteria to dot set location employee dot get location. So the criteria is ready now, and we'll pass it over here, and the find employees method returns with the type of page of pagination. So I want to see how many elements is found in this page results. So as we are just sending a single employee object, so the DB should have only one employee object, and the page result of this find employees method should also contain the total elements should be the one. So dot get total elements is should be double equal to 1. Now the compiler is gone. So what I am doing here is this await method should wait until this condition becomes true. So when this condition will happen, once the employee, once the message sender from devon4j Kafka sends the message, the listener will consume the message, and the message processor will save it in the DB. And yet we are yet to implement it, and but this is the test which we are going to do it. This is a complete integration test, and you can add more methods to this await, like example at least and at most. You can set your own time how long this asynchronous process is going to take to make this conditions fully satisfied. If you don't specify any methods like at least or at most over here, by default it's going to take 10 seconds. So this condition should be true within 10 seconds of execution of the server. Now let us go and create the listener and the message processor, which will save the employee object into the DB. Now let us create the listener class. So let me close this general, open employee. Under the service impl rest, I'm going to create one more package. It's Kafka. Create Kafka, and I don't want the rest, I want Kafka. So it got created, and inside this I'm going to create the class which will be, we are going to save the employee, right? So save employee listener. So delete this author tag at the rate named. Following the Devon framework standards, and here I want to use the message retry pattern, which I already said part of devon4j Kafka. So if some exception happens while processing the consumed message, I want it to retry, and we also added the property for which exception it should get retry. So there is a class private message retry operations. So as we used string, here also it should be a string, comma string, and message retry operations and inject it. So this interface has the method process message with retry, which will process the message, and when any exception happens it will retry. So the next one will be, we need to inject the message processor, and again it's from devon4j Kafka. So it's, if you see here, the interface message processor, and it's from devon4j Kafka. Double click on it, and same, it will should be a type of string comma string. And the object name will be message processor, and inject it. Now let us create the method which will consume the message. So it will be public void, let us keep it simple, as consumer, which will have the consumed record, which is consumer record of type string comma string consumer record, and we need to use the acknowledgement. Okay, yep. Now we need to add the spring Kafka annotation, which will use to consume the message and pass the value to this method with the attribute consumer record, that is at the rate Kafka listener. And these has multiple attributes. We will add one by one. The first one will be the topic. So the topic is the one which we passed in the property file. Let me open the property file, and in some, copy this, Control C, and go to the listener class and Control V. So this message listener should consume the message for this topic, and let me add the group ID. Group ID is equal to the same, go to the application.properties. We would have been given the group ID in the consumer properties. This is the default, or else you can use it this, keeping it more spring manner. Yeah, this looks more beautiful now. And one more thing, for the acknowledgement we need to use the container factory, which we made a configuration for that, for the bean. As I said already before, devon4j Kafka provides the configuration classes for both producer, consumer, and retry operations. So container factory is equal to, we need to use the method name of bean, which is Kafka listener container factory. it's double equal to here and save it. Why I added container factory means we are using acknowledgement. Why we need to use acknowledgement? After consuming the message for the given topic and after processing it, we need to acknowledge the listener, or else the listener will be keep on consuming the message for the topic given. Now let us implement this method. What to do with the consumed record? Okay, now I want to process the message with retry pattern. So let me call this object this dot message retry operation dot there is a method process message with retry which expects the consumer record and the message processor. So click that. Consumer record is the one which we did and the message processor is the this. And after this we need to acknowledge the listener. So what we need to do, we need to call the object acknowledgement dot acknowledge of. So this will acknowledge the listener that the message has been consumed and processed. Now let us go and implement the implementation for this interface message processor. So under the same Kafka package, let me create one more class, message processor implementation or IMPL. Remove the author tag, which should implement message processor of devon4j Kafka. It should be a type string. To remove this, now we need to implement the method from the interface. Add unimplemented methods. Yep, remove the to do comment. Now let us implement this method. Okay, now let us implement this method. So our consumed message will be of type string, right? We need to convert it into employee ETO in order to save this into the DB. So what I will do is using again the object mapper, new object mapper dot read value. Read value, the source will be message dot value. That is the value we passed, which is of type string in the producer record. So I want to convert this string message to the employee ETO class. Employee ETO dot class. So save it. And there is a compiler error, of course, which because it throws JSON mapping exception. Surround with try catch, obviously. So I don't want to keep these to do statements. Let me remove it first. And this e.print structure is also. Let us add some loggers. Private static final logger interface from slf4j log equal to logger factory class from the slf4j.get logger, and the class name will be message processor impl.class. To use named yeah, just like you add component component in the Spring framework. And we need to inject one more field, that is employee interface from the logic API, employee logic API, which interacts with the DB with the UC methods, UC logic methods. Employee and inject it. Okay, so I think we don't need this catch block. Yeah, so let us add log dot one will be good. Log dot one error while converting string to employee ATO class. Pass the string value. Consumer. Oops. Oh no. Again. Error while converting string. Converting message to employee ETO, comma message dot value. Okay, let us keep employee ETO employee ETO equals null and assign this variable to this method employee ETO. Now employee ETO. Yes. Now if employee ETO not equal to null, then this employee call the employee object dot save employee and pass the employee ETO. So that's all. We are done with the work with the processor IMPL. So what am I doing is once the message processor from devon4j Kafka sends the message to the Kafka broker, this listener class will consume the message which has the same topic mentioned over here. So once it consumed, it passes the consumed record value to the method process message with retry along with the message processor. This is an interface from the devon4j Kafka, and we have created implementation for the message processor, and the implementation for message retry operations is already available and part of devon4j Kafka. Let us have a look at the message processor IMPL. So this processor IMPL, what it does is with the consumed message, as the value will be this string, it tries to convert the string value to the employee ETO, and that employee ETO is passed to the method save employee, which will save the employee object into the DB. We are going to test this with the test case which we have written. Now let us have a look how to run this. As I said before, this is an integration test. So it is important to run the Apache Kafka server at the background before starting the test. You need to download the Apache Kafka from their site. I have already downloaded and kept it in the C folder. I opened system C and the Kafka, and once you have opened this folder, right click and open the command shell over here, and first we need to run the Zookeeper Server, which manages the Kafka brokers. So this is the command to run the Zookeeper. So paste it and click enter. So this has started the Zookeeper server with the port 2181. And again open another command shell and paste the command to start Kafka server. So click here, paste, and click enter. So the Kafka server has started here with the ID 0. Now let us go to the test class and run this test. Right click, run as JUnit test. It's launching. Let us have a look what is the result of the JUnit test. Yeah, the JUnit has been passed. You can see the result over here. That's a green tick. JUnit has been passed, which means the producer has been sent the message to the Kafka broker. The asynchronous process of listener which consumed the message, and it sent the consumed message to the process message with retry pattern along with the message processor, and the message processor converted the message from string to employee TO and saved it in the DB, and we tested it through this integration test, and all this happened within 10 seconds of time. So this condition has been satisfied when only when the employee got saved in the DB. So as you saw before, we started the Kafka server manually in the command prompt. If you are using Docker images, you need to import the correct port number as a broker string in the application.properties. So as I used the Apache Kafka server directly, it always connects to this port number, which is localhost colon 9092. If you are using Docker images, then the bootstrap servers will be different, and you need to add that here correctly. So this is version 1 of Kafka, devon4j Kafka. In the next version release, we have planned many things like authenticating the JWT token and implementing retry pattern for a particular specific topic. Like if there are 2-3 message listeners, and for each message listeners, different types of retry should be happen. It's all included in the version 2. Let us have a look once it got released. Until then, bye and happy coding.